Hello, fellas. Welcome to the MJ's Brain Boost. Today, we are going to deal with the very basics of the trigonometry. We're gonna cover the definitions, the reductions, reference angles, negative angles, special angles, and the co-ratios. This content is good for the grade 11s, both the grade 11s and the grade 12s. Okay, please don't forget to like, share, comment, and hit the notification button below so that you get notified once we upload new content. All right, welcome to the MJ's Brain Boost that actually works. Stay tuned. So we're gonna start with the basics. We have to know the definitions in the trigonometry. So we are having the Cartesian plane like this, which is divided into four quadrants: quadrant one, quadrant two, three, four. All right, and usually we are using what we call the cast. We are using what you call the cast. All right, is the simplest one. Cast, and then all the trig functions are positive in the first quadrant, and only sine is positive in the second quadrant, and it means cosine and tangent they are negative. And in the third quadrant, only tangent is positive, and sine and cosine they are negative. And in the fourth quadrant, only cosine is positive, and the rest they are negative. All right. So, but the value of r is always positive. So we are looking at the right angle triangle. Here you are having your hypotenuse. All right, here you are having your x. Here you are having y. This one is always positive, and then these they are changing. Remember, this is your theta, and then because remember this is the right angle triangle, but because here we know that the theta and this one they must add up to 90 degrees, so it means these two they are complementary, they must add up to 90 degrees, so it means this one it will be 19, so it means this and that, so they um complementing each other, right? So you're gonna learn more about that as we're gonna be dealing with the core ratios. All right, so we're just dealing with the very basics. Yes, so if you want to, let me wrap this. All right. I want to make sure that this lesson is not that long. I want to keep it short and simple. All right. So so far you already know this. We usually use what we call soccer tour. All right. So we know so from soccer tour, it means that sine is opposite over hypotenuse. So you put your theta here, opposite of this theta, and then adjacent of it. So sine theta, it will be the opposite. All right, and the hypotenuse. All right, or y over r. All right, so or y over r, this is r, this is x. All right, so this is how you define them by SOHCAHTOA. All right, so we do not use the cosecant, the second, and the cotangent, all right, in grade 11 and 12. So it means we are gonna be focusing more on these ones, all right. But now, remember, we are defining them. That's why we're saying definitions. So, we are having this, all right? You always have to extend this towards your axis. Then now it means here you are having your right angle triangle. You're still having that x, that y. All right. So now can you see that this whatever, let's say they gave you something like 2 and 1. So you know that here you're having 2, and then here you'll be having 1. So that is the definition. All right. I hope it makes sense. I hope it makes sense. And then now all right. So let's work on this. Let me make my screen to be as clean as possible. All right. So let's work on this one. Um, so they say if 13 sine theta is equals to 5 and we're having the restriction that theta is an element of 90, ranging from 90 to 270. This is the restriction. So it means now if you are having Cartesian plane like this, you are having 0, 90, 180 and 270. So they said theta ranges from 90 all the way to 270. So it means you're either in the second quadrant or the third quadrant. So it ranges between second and third quadrant is the restriction that they gave you. So find, without the use of the calculator, the tan theta, sine theta plus cos theta. All right, and then after that we will have another question. So we'll say, well, you write your thing here. You say 5. All right, so you first have to isolate things. All right, you isolate your trig functions. So you'll say you divide both sides by 13. So you'll say sine theta is 5 over 13. So now you know that soccer 2, so you know that sine theta is equals to opposite over hypotenuse, or y over r. All right, so it means this 5 is your y, all right, and then this is your r, or this is your opposite side, and then this is your hypotenuse side. All right, so it means now you need to find your x in this case. All right, so what do you do? So it means you can use the theorem of Pythagoras. So you know that according to the theorem of Pythagoras says r squared is equals to x squared plus y squared. All right, and then what do we want? We need x squared. So we'd say, well, x squared is r squared minus y squared. All right, and then we can say, well, this is the square root, and then immediately when you put the square root, it means you are left with x, and then you put plus minus. Immediately when you put the square root, you say plus minus. Then now, what is your r? Your r is 13 squared minus, what is your y? Your y is 5, all right, squared. And then where is my calculator? So you say the square root of 13 squared plus your, okay, oh, all right, not plus but minus, minus 5 squared. All right, it gives me 12, and then it means here you'll have a plus minus 12. All right, x is plus minus 12, but therefore what is x? And then you say, well, let's draw our okay, before you come up with this conclusion, you say, well, sharp, where the sign is positive, you see our sign is positive, and then you say, well, let's use cast, let's use cast. So you'll say cast, and then we say sine is a positive in the second quadrant. It means now you have to put your right angle triangle. You always have to draw. You have to put your right angle triangle in the second quadrant, and then you always extend this to the y to the x-axis. Then this is your whatever, your right angle triangle, and then this is your 90 degrees, and then this is your theta. This is your theta. And then now let's see, you have your y, which is 5, you have your hypotenuse, which is 13, and then now obviously your x is 12, but do you see where we are? We are towards the negative side, so it means now this is negative 12. So therefore you say my x is negative 12. All right, so there's a mark for doing all these things. So now we have defined everything. So it means we have got our x, you've got your y, you've got your x, your y, and your r. Then now what do? We now answer our question. All right, so we say tan theta. So what is tan? Tan is opposite, so tan is opposite of that theta, and divided by hypotenuse. So what is opposite of theta? Opposite of theta is 5, and then not hypotenuse but adjacent, sorry, and then adjacent of that theta is that is minus 12. So it means this is minus 5 over is minus 5 over 12. Then I hope it makes sense. Then you will say, what is this value that we get over here? Then you will say, well, we have sine theta. We have sine theta plus cos theta. What is the sine? Sine is opposite over hypotenuse. So you'll say what is the opposite of this is 5. Hypotenuse is 13, and then plus what is the plus, all right, then you say what is the, you can do this plus and do this and say what is the cosine. Cosine is the adjacent is minus 12 divided by adjacent over hypotenuse which is 13. So then you can say, well, this is they said without any use of calculator, they said without the use of a calculator. So you can say the this and that, you can say 5 over 13 minus 12 over 13, and then okay, so let's create a space here, then take the common factor or common denominator, is 13, and 13 divided by 13 is just the 13. 13 times 5, no, 13 divided by 13 is 1. 1 times 5 is 5. And then you've got minus, then 13 divided by 13, this 13 divided by this 13, you've got 1. Then 1, 1 times 12, it's just the 12. And then if you say 5 minus 12, if you like calculator like me, you'll just get minus 7 over 13. All right, but they said without the use of calculator, so so you obviously you just know that 5 minus 12 is 7. All right, but because you're subtracting smaller number from the bigger, then you get to the minus. So therefore, I'm sorry about my messy screen. Then you'll say therefore this is my answer. All right, and then let's change the color and do. All right, who is that? I don't know what's happening, but it's fine. So, but they say now another one. They say given 5 cos A is equals to minus 4, and A is greater than 180. So it means if it's greater than 80, so if it's greater than 80 is between third quadrant and fourth quadrant. All right. So then you will say, well, 5 cos A is equals to minus 4. Allow me just to write here, and then you'll say cos A is minus 4 over 5. All right, you'll say cos A is minus 4 over, because A is minus 4 over 5, and then you say, well, we have isolated our trig function. All right, you have isolated our trig function or our ratio, but now cosine is negative, and then cosine is negative. So but remember, it's between 3 and 4. All right, 3 and 4. And where is cosine negative? It's exactly in third quadrant. It's exactly in third quadrant. It means now it's messy, but now it means our thing, our right angle triangle, we're gonna draw it here, but always we must extend this to the x-axis. All right, this is your right angle triangle. All right, this is your right angle triangle, and then this is your theta. So you can just do it like that, but now then what else? Oh, yes, what else can you say? Then we know you've got where is it? We know from soccer tour, this is adjacent, this is adjacent, which is x, and then hypotenuse, which is our r. So it means we've got this part. It means for us we've got this part, which we've got minus 4, okay, here, and then we've got our r, which is our r, which is 5, then what is expected of us is to find the value of y. So what do? We use the theorem of Pythagoras. All right, so where's that theorem of Pythagoras here? So we know from this we can make y the subject of the formula, so we can say y squared is equals to r squared minus x squared. All right, allow me to just shorten everything all together. So what is our r? Our r is 5 squared minus our x is into minus 4 squared, and then everything square root plus minus, then y, it will be then our y, it will be, all right, okay, and then I get plus minus 3. Then where is it? Yo, it's messy. Sorry about that. Then it's plus minus 3. So our y is plus minus 3. But you can see here, remember our we are remember we need to be careful of the sign, but we are in the third quadrant. So in the third quadrant, what do we expect? We expect the this y to be negative also, so you'll have negative y. All right, so it means our y is negative. All right, so we need to be careful of that. All right, so now we can find the, all right, we can now find our tan a. So allow me to just squeeze everything all together here. Our tan a, tan is what is opposite, so its opposite is minus 3. Opposite is minus 3, and then opposite of this theta is minus 3, and then adjacent is minus 4, and then it's minus 4. Positive and positive, they'll cancel each other, and then you'd have 3 over 4. Basically, that's how we deal with these what do you call these definitions. All right, I hope it makes sense. We can now move on to nothing. Yo, so it means we just have to rub everything. My screen looks messy. All right. It's taking our time. And I promise I want to make this thing um, as short as possible. But let's see how far it can go. So yeah, so now we are into another chapter, which is what you call the reduction. So you know that to reduce is to make something simple. All right. So reduction, we are trying to make things to be very simple. So um, the steps that we take in this chapter, the first step is to locate the quadrant. Are we in the first quadrant, second, third, or fourth? All right, you are locating the quadrant. All right. So we always start by finding out where the angle lies on the Cartesian place. All right. And then step number 2, we decide the sign using the all student take calculus. Most of people like this, but now I like cast. All right. Yes. So you decide the sign by using the cast, okay, diagram. All right. Like what we did previously. So you reduce the angle. When you are reducing the angle, you're using what you call the reduction formula. All right. Now we're trying to express the given angle in terms of the acute angle or the reference angle, which we're gonna deal with in the greater details in just a few. But the acute angles, these are the angles which are less than 90, and which we know them. Okay, we know them. For example, sine of 30, sine of 45, 60, for example. All right. So yes. So write your final simplified ratio. Now express your answer using the reduced angle and sign. All right. So you need to, I know you're familiar with this. All right. I know you're familiar with this one. So this is our cast, and then this one we are having everything in the first quadrant. We're just having theta, and then in the second quadrant we're having theta minus 180 minus theta, and then in the third quadrant we're having 180 plus theta, and then in the fourth quadrant we're having 360 minus theta. Note that this one, all right, it's for a general formula. All right, this one is for general formula. All right, so this one will just help you to all right, to get all right this. All right, you are having is the general formula for the angle, or the general angle form. All right, so if for example you want to find the whole angle, all right? But if you want to find okay, now this would be the using the reduction formula, all right? In the first quadrant, everything is the same, all right? Sine theta, cos theta, tan theta. That is when we are doing all these things, we are trying to make sure that things are in the first quadrant, all right? Because they're simple and easy, all right? So in the second quadrant is 180 minus theta. So if you're having sine 80 or sine 180 minus theta, you're just having sine theta. And then remember, in the second quadrant, sine is positive, and then everything is negative. Then cos 180 minus theta, because cos is negative in the third quadrant, in the second quadrant we put a negative cos theta, and also tan is negative. So that's why we get this. And then in the third quadrant, you're having 180 plus theta, but sine in the third quadrant is negative. Sine and cos they are negative, but tangent is the positive. So that's why we are having tan that is positive, but everything they are negative. But in the fourth quadrant, only cosine is positive. All right, that's why cosine is positive like this, but everything they're going to be negative. So like we said, the first thing we're determining the quadrant. We are checking the quadrant to tell us whether our sine or cosine or tangent they're negative or not, or positive. Okay, so then we're using reduction formula, gives you the acute angle. All right, so this would be your acute angle. So when you're doing this, you are trying to get your acute angle, so which is easy to use. So always then okay, then you're using cast in your compass, in or your cast is your trig length. Then always reduce to positive acute angle before using the values, or before using those special angle values. All right, but we quickly gonna in just a few, we're going to learn about the special angles. Remember, today we are dealing with the very basics of the trigonometry. Like I said, we're going to be dealing with the acute angle. So the reference angle is the acute angle, which is the angle that less than 90, which are formed between the terminal side of your angle and your x-axis. I mean, if you are having your whatever like this, all right, where you are starting, for example, where you're starting, it will be your starting point, and then where you stop. If you stop here, this will be your terminal side. All right, this is will be your terminal side, and then it means we will stop here. All right, because this thing initially it was like this, and then you, all right, or counterclockwise like that. All right, until you are 90, until you are 180, you are 270, and you are 360 like that. All right, I hope you remember that from if you familiar with physics, when we're dealing with the work, we are using this. All right, but because you stopped here, where you stop, we say is the terminal side. All right, so the reference angle is the angle between your terminal side of your angle and the x-axis. So we're just basically checking how far are we from the x-axis. All right, when we're using this. All right, so think of the reference angle as the helper angle that tells you how far your angle is from the x-axis. It's always positive and less than 90, no matter which quadrant you're in. So because all trigonometric ratios are based on the reference angle, it means now the sign that is positive or negative of the ratio depends on the quadrant. All right, we know that. So we use the reference angle to find the size of the ratio and the quadrant to decide the angle, to decide the sign, the sign. Sorry. So the quadrant is the side, the sign, and the size of the ratio, we get that from the reference angle. And then once we get that you know, size, then we can use special angles to know the value of that. All right. So um, the reference angle. All right. So we are already familiar with this diagram. We're already familiar with diagram. So you know, is to get the original angle. All right, is to get the original. This one is for the original angle. All right, from the reference angle. So reference angle formula. All right, so this is the same, that is the same. The only difference now is this part. All right, instead of 180 plus theta, you say theta in this, you say theta minus 180. So this is when you are using the reference angle, all right, or you want to find the reference angle, and then 360 minus 360 minus theta is just the same. All right, but when you want to find the original angle, now you say 180 plus. Okay, so why do we use all these things? Because angles like 132, 10, and many others, and also the negative angles that we're gonna deal with in a few, are hard to work with directly. So, but the reference angle are small and easy, like 30, 45, 60, because we know the sine, cosine, and tangent of those using what you call special angles, which we're gonna learn in a few. So our aim is to find these simple or the acute angles, right? Because we know their values by heart. Okay, not just to memorize them, but we know we can use the right angle triangle to find them. All right, so let's remember the reference angle. We're trying to find how far are we from there, from the x-axis. So for example, given the 210, remember the first thing is we need to know in which quadrant. So 210, you can tell 180 to 270, so it's in quadrant 3. All right, 210 is in quadrant 3, right? So then we want to know how far is it from the x-axis. So to know how far is it, remember, it means we want to find the reference angle. All right, so it means we say reference angle. I told you that in the third quadrant, the reference angle, we must say theta. So you'll say the reference angle, all right, is theta in the third quadrant is theta minus 180 degrees. So our theta, given theta, or the original angle, all right, or we can just say angle minus 180. All right, so our angle is 210 minus 180 degrees. All right, and then is 30 degrees. Now it means this 30 degrees is our reference angle. It means it's how far we are from it's how far we are from this x-axis. All right, but if we were given the reference angle, now I want to show you this. If we're given the reference angle and we want to find the original angle, then therefore you were gonna say, well, you're gonna say 180, which is this one, plus the reference angle. Then you're gonna say 180 plus reference angle, which is 30. Then 180 plus 30 is obviously 210. So I just wanted you to be familiar with this one. All right, I hope these all these things, they make sense. All right, that is reduction. But remember, why we are doing these very basics. All right, so that, remember, in the exam, you're gonna have to combine everything. All right, you're gonna combine, for example, definitions, for example, the special angles, corratios, trig functions, identities, and other things. All right, I hope you make sense. It makes sense, sorry. So negative angles. So when you're having negative angles, the first step is you must always add 360 to make the angle positive, and then start to now identify the quadrant, then the sine, and then the reference angle. Then after that, attach the correct sign and solve. All right. Like I said, for example, now in this case, you are given the negative angle. The theta is negative 120 degrees. So automatically, you know that this is the negative angle. So if you're given negative angle, you just have to say 120 plus 316, and then it will give you 240 degrees. It will give you 240 degrees. Now it means adding 360, you just wanted to make this thing to be positive. Now once it's a positive, you follow what we just learned previously, which is the reduction. So you start to say, well, following my whatever, so it's 100 and whatever is 270 is 360 is 0 is 90, like that. So where's 240? Obviously in the third quadrant, all right? So 240 is in the fourth in the third quadrant. So then you say, well, I know this is my cast. And then I say, well, where is in the third quadrant, my turn is positive, but what did we're given cos in this case. So we say cos of negative 20, so 120. So we know our cosine will be negative in this, right? Will be negative. So we'll say, well, all right, because cos is negative in the third quadrant, then what do we do? Then we say we already got the sign. Remember, we got the sign. Okay, so cast. All right. So then we say, well, um, then the because cosine is negative, then we say, well, let's find our a thing now. We are doing reduction now. Remember, it's like we say cos of negative 120 is exactly like cos of 240. These are just one and the same thing. Then we're dealing with the reduction. But in the third quadrant, what have we realized? What have we learned? Sorry, we say is in this case this one we say theta minus 180. Then theta is this 240. So it means you can say 240 minus 180. So 240 minus 180, it will be 60. So it means now, but remember we already determined the sign. The sign in the third quadrant, we said the cosine is negative. So we say cos what is cos 60. That is the reduction, right? Because here we got 60, but we said cosine is negative. Therefore, then we can say, well, cos minus 20 is exactly minus 120 is exactly like minus cos 60. But because we know that 60 is a special angle, which I'm gonna explain in a few, it's a special angle, but we know that cos 60 in terms of special angle, cos 60 is just, remember this is negative, cos 60 is just half. All right, so can you see that but when you're having negative angle, you can at 360 make it positive, then follow the reduction steps that we just learned. I hope it makes sense. All right. All right. Now, these are special angles. I mean, the special angles, they were derived from this. All right. Remember, let's say we need sine 30. Sine 30. Remember, we have a soccer. A tour. Sine 30 is here. What is the opposite of 30? The opposite of 30 is 1. So that's why we have 1 here. Then over hypotenuse is here, is 2. That's why sine 30 is 1 over 2, right? And then we can get another one. Let's say cos of 30. Cos of 30, we know this is the opposite of 30. Then what is the adjacent of 30? It will be root 3. And then our hypotenuse, it will be this. So all these things, they were derived from this. All right. You can get this. That's why we say you don't have to memorize them, but you have to know how to work them out. All right. You have to know how to work them out. But another interesting thing is this. These things they were derived from this. Okay. So you are having these coordinates. You are having these coordinates. These basically coordinates for the special angles. Remember, you must always know that your x coordinates, they are given by cos theta, and your y coordinates, they are given by sine theta. All right. And then now we know that, for example, here we know that if we say sine if we say sine of 30, all right, if we say sine of 30, we're gonna get your sine of 30, say sine 30. For example, we can just cheat. Sine 30, for example, is half. And then what is cosine of 30? So cosine of 30, and not sine of half, but cosine of 30 is root 3 over 3. All right. Cosine of 30 is root 3 over 2, like that. All right. So I want to show you something. Now it means, for example, when we need the coordinates for special angles, all right, for special angle 30. So it means coordinates, we will say, remember, sine is y, and then cos is whatever, cos is y, is x. So we say our x is cosine is this, and then you will say this is your, now is your half. You can, I hope you're following. So is for example 45, you can say 45, and then you can say 60. All right, so that's how you get your coordinates for your special angles. All right, I hope it makes all sense. It makes sense. But special angles are angles where the values of sine, cosine, and tangent can be determined without the use of a calculator. We're just using these. So these angles include 0, 30, 45, but they use the most common used ones, 35, 40, and 60. All right. Instead of memorizing the values, you should learn how to work them out using the known triangles or the unit circle. All right. So this is the unit circle, or this is the whatever. But if this one is complicated for you, the simplest one is this one. All right. I hope it makes sense. Um, Ladies and gents, let's move on. I think we are already consuming a lot of time, but I hope you are following. I hope you are following. All right. So these are the special angles that we're talking about. So they said, now without the use of the calculator, determine sine. Without the use of the calculator, determine the 3 sine 30 tan 45 cos squared 30. All right. So I hope these things, they make sense. But um you can use those triangles, all right, but for us, for now, we can just cheat at the moment. All right, so we'll say, well, this one is remember they said without the use of calculator, so we cheat but act like we are not cheating. I hope it makes sense. So we are here, so here is just 3 over 1, and then say multiply by. So but now you can just press on your calculator. They won't know that you're pressing your calculator, isn't it? But you can use those triangles, all right? But we are just saving time here. So sine of 30 is half, and then multiply by tan 45. Tan 45 is 1. Tan 45 is 1. All right. Tan 45 is 1. And then multiply by, no, what am I doing? Yes, tan 45. Yes. Okay, sine 30. Okay, yes. And then what else? And then we can say cos squared theta. You say, all right, the cos of 30 is root 3 over 2. So this will be root 3 over 2, but we still have um, squared, like that. So you can have something like that, you can have something like that, and then you come back and say, now you can try to multiply your things. So say 3 times 1, we can get 3, and then over 2 multiply by root 3 over 2 squared. Then this and that, they can cancel each other out. Then you are left with 3 over 2 multiply by 3 over 2. Then can find common denominator, or you can just, you say 3 times 3, and then you say 30 times 3 is 9, and then 2 times whatever, it's 4. All right, it's a 4. I hope it makes sense. All right, I hope it makes sense. And then now you say tan 15, all right, a tan 315 minus cos that, then you can say, well, this would be, let's do that, and then say, all right, okay, let's draw our cast. Okay, remember we do not need any use of to use cast because these ones they are acute. They are here below 90. They're ranging from 0 to 90. So now we need to use our cast. We need to use our cast. So we know it's 100, 180, 270, 360, and 19. So 315 is definitely here. So in the third quadrant, and then in the fourth quadrant, sorry, and then the fourth quadrant, only cosine is positive. It means this one is negative. So you'll say it's a negative. Then now, but let's reduce this. Let's reduce this now. Automatically, we know that here is 360 minus our theta. So we will say 360 minus 315, which is 45. So you'll say 360 minus 315, which is 45. This is the reduction. We're dealing with the reduction here. So you say, so this is exactly like a tan 45. All right, it's like exactly like tan 45, or you can say tan um you can say tan um um yeah, basically you can just let's simplify it, okay, to make our life simple. You can just say tan 45. Yes, let's not waste time. And then you say minus, and then let's see, cos 240 is here, and then only tan is positive in the third quadrant, and then it means now here cosine is negative, and then it means now, but 240 here, what do we have? We are having if we say 180, we are having 240 minus 180, which is 60. Remember here, what did we say about reference angle? We say it's a theta minus 118. So here you will say um, 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 240 minus 180 is 60. Therefore, you will say it's a cosine of 60 degrees. Right, allow me not to just but it's fine. Let's put them, and then we still have got this squared. Then now, remember, they said without the use of a calculator. Now, because now this is a special angle, you can now say tan 45 is a special angle, right? So we know that tan 45 is minus 1, then minus into, all right, but we can just say this first. Then what about this one? We know that cos 60 is a special angle, remember. It's 1 over 2 and then squared. Positive times negative, negative times negative is positive. Then you'll have, all right, oh, but it's fine. All right, it's fine. If we say negative half, if we say negative half squared, if we say negative half squared, negative half squared, all right, we'll just have we'll just say negative 1 minus is this one. But now this one, we know 1 squared is 1, so you can just say 1 squared is 1, and then over 2 squared is just 4. Remember, everything, if you put negative and then you square it, it will just be positive. All right, now this one, that's why we still have 1 over 4. Then you're having that, and then you will say, well, I know this one is like that, and then I can make 4 common factor or common denominator. 4 divided by 1, it's 4. 4 times 1 is 4, minus 4 divided by 4 is 1. 1 times 1 is that. All right, or remember, we still have minus here. So we still have minus here. So we still have minus here. Then minus 4 minus 1. Then this is like minus 5 over 4. So therefore, this one is like minus 5 over 4. All right, so that's this is how we are using our special angles. All right. I hope it makes sense, and allow me to wrap these things so that we clean our screen. Okay, sorry about that. So, um, all right. So now let's deal with this one. So we are working these ones without the use of a calculator. Evaluate 3 sine whatever that also this one we dealt with it. I'm sorry. Now we are into core ratios. So core ratios, I already told you, good people, that we are using right angle triangle. All right, right angle triangle. So we are using right angle triangle. We know some of the angles in a triangle must be 180. All right, so automatically we are having 90. So it means this one is 90, is 45, 45. Basically, we are left with 45 and 45. So if you're having theta here, so you are making this angle to be 90 minus theta. So then it means this and that theta and that's one, they are complementing each other. It means they must add up to 90. So this is the thing that I want to give you to bring to attention. But so then we would say sine and cosine, they are co-functions. So we say that sine and cosine, they are co-functions. So it means that the two angles are complementary. All right. So it means their angles are complementary. It means that they must add up to 90 degrees. All right. So now this brings me to say now we are having co-function identity. So it means remember we are having if you're having sine theta, we are expecting to get cos theta. If you're having cos theta, we are expecting to get sine theta. But remember, these things that they are co-functions. All right, but sine theta, all right, because it's complementing with 90 minus, all right, it doesn't matter. Theta is complementing with 90 minus theta. It means you can say 90 minus theta, and then here I can also say 90 minus theta. So this is exactly like that, all right, because these things, they are complementary, they are co-functions, all right. But now immediately when you start to add you can now add positives, which I'm going to show you just in a few, but these are what you call core ratios. Now you can we are done with these ones. I hope you still remember them. Here they. Now you can also add, all right, you can also add, but now let's imagine now, okay, it's a little bit tricky now. But now this is 90, 180, 270, and 360 and 0. And this is our cast. Where is 90 plus? It's here. This is a 90 plus, right? So it means now sine 90 plus, we know sine its co-function is cos, right? So, or we can say cos theta is equal to sine theta, not sine theta, but sine, all right? Sorry. But, oh, what did I do here? Sorry, we should say cos. Then the reason I wrote that was because we know sine and cos, they are co-function, but I forgot to scrape it off when I'm including another angle. All right, sorry about that. So it's sine theta, but this is sine into, all right, because they are co-function. But 90 plus, all right, 90 plus theta, it's here and it's in the second quadrant, and sorry about that, and sine is positive, so we know sine is positive, we leave it as like that, right? But once we say we start with cos of 90 plus theta, 90 plus theta, it will be in the second quadrant. 90 plus theta is in the second quadrant, but cosine here is negative, so that's why now cosine is negative, so that's why now our co-function, it will be minus sine. I hope it makes sense. right? So these are co-functions or co-ratio identities, right? So how to simplify trig ratios step by step. When simplifying, sometimes something like sine 120, ask yourself what quadrant is that. So we know 120, this 100, usually it will be in the second quadrant. What is the sign of the ratio? Right, we know here only sign is positive, right? So what is the sign of the ratio in the quadrant? The second quadrant, sign is positive and cos is negative, which is complementary, right? Use corratios if the angle is expressed. Okay? Use corratios if the angle is expressed as. All right? So let's do this. Let's clean our. All right. As 90. All right. We know we use corratios if we're having something like sine 90 minus theta or sine, for example, 90 plus theta. That's what this means, all right? If you're having 90 minus theta or 90 plus theta, right? That's when you're using corratios, all right? So why do we use this? When simplifying expressions like sine 90 minus theta, it's easier to rewrite them using identities so that you're working with acute angles, that is to say angles that are less than 90, which are simple to evaluate and understand. And we know they are part of the special angles. And we know the special angles, they are simple. All right. So now, all right. So let's find this. So we're having cos 90 plus theta. Use the identity cos. We know we're going to use identities minus sign. We know this one. We've learned about it. So instead of working with 90 plus theta or x, you now work with minus sine x, which is much simpler. So it means you need to note this. Always change to an acute angle before using corratios. All right, we need to change to acute angle, something that is less than 90, which now you know how to do it. So this means if you're working with something like sine 90 plus, write it using the identity so that you are dealing with just a sign like this. This is exactly okay, this is exactly what we are talking about, this statement. So we do not ever use 270, likely because 270 leads to undefined or less useful values in this context. Okay, so please remember that for correlations we are not using cos of 270. Okay, let's clean this and try to find these ones. Okay, so to solve these ones. Okay, okay, so where do we change the color? Where do we change the color? Color. Okay, it's fine. Doesn't want to. Okay, it's fine. Let's just work with this one. So they say write the following as a ratio of 30. Okay, they say write the following as the ratio of 30. All right, so you have got cos 60 degrees. Cos 60 degrees. So what do we know from this cos 60 degrees? All right, remember we are dealing with core ratios. All right, we're dealing with core ratios. So before that, we should make sure that this is 90 um, minus 30 degrees. So remember they say you're expressing this in the form of ratio of 30. So we know to get 30 from 60 we must say 90 minus 30, right? So now we know now what have we learned. We learned that cos theta complements with sine, sorry, 90 minus theta, like that. We know we have learned about this. So it means now we can say, all right, so this is the okay, it's like us saying, okay, sine 30 degrees, right? And so these are co-ratios. So then now we also have got sine 240. So far we know that 240 is in the cast, all right, 180, 270 is in the third quadrant, 240 is in the third quadrant, and the third quadrant sine is negative, so you have to say sine is negative, and then we know it should be sine 180, sine 180, sorry about that, sine 180 plus 60. All right, we're having that, and then we know that this is exactly like minus sine 60. And now when we have minus sine 60, we are going back similar, it's more or less the same like that, the previous one. So you say sine 60 can be exactly like 90 minus 30. All right. Allow me to not just write these degrees to save time. So, and then now we know that sine and cos, they are complementary. So this one, it will be minus cos of 30. I hope it makes sense. Then now they say we need to simplify. So you see that we have got the co-ratios here. We need to simplify 2 sine 90 minus alpha plus cos 180 minus alpha divided by minus sine 90 minus alpha minus 2 times cos of 360 minus alpha. All right, and we need to simplify this. So let's put everything together. Let's put everything together that we learned. So we know that when we are having this, okay, we are having this, okay, is in the form of the reference like style. All right. So what will we say? We say we know these the form part of the co-ratios. All right. So we know that we will say, well, this is nothing but 2 cosine of alpha, and then plus plus, this is our plus, and then we can say, well, we're still having this plus, then but now we are working with this part. Then we say, well, 180 minus is here, 180 minus it's here. All right, and what do we know about this part? What do we know? We know that only tangent is in the third quadrant. Again, 180 minus theta is in the or minus alpha is in the third quadrant, and only tangent is positive. It means cosine is negative. So you will say minus cos. You can say minus cos alpha. All right, and then divide by the bottom part. You will say all right. It's simple. This minus, then it's a co-ratio. It's a cosine of alpha, and then um, multiply by, so remember this is multiply by, sorry, multiply by minus whatever. So you say multiply, no, it's not multiply, it's minus, yes. Then you say minus, and then what do we have here? Then we say, all right, we are having um, the 2 cosine of 360 minus minus alpha. Then what do we know? We know that now this one is exactly like 2 cos of alpha, because we are having in the fourth quadrant 360 minus, and then we know that cos is positive, so we leave it as is. Then we like, now let's try to simplify things. Then all right, so we can say 2 cos alpha, positive and negative is minus cos of alpha divided by minus cos alpha minus 2 cos alpha. Then what do we have? Then we can say um, we are having we are subtracting 2 from 1. We are having 2 of cos alpha, but then we are subtracting 1 cos alpha. Then we're gonna remain with only cos alpha. I hope it makes sense. And then at the bottom would be like it's 1 is like -1 -3. -1 -2, then we're gonna have -3 cos of alpha, -3 cos of alpha. Then now we can say, well, okay, no, it's fine. We know the this that we can say this and 1 and this and that they cancel each other, then you will have 1 over -3, or you can say it's equal to 1 over 3. Then it's well simplified. Hope it makes sense. All these things, they make sense. Okay, hope they make sense. Let me wrap this so that our screen is clean. All right, and now examples are now we this is towards the end of our lesson. Now, for example, simplify 210. Now, just combining everything all together, you find the quadrant, and then 210 is in the third quadrant, and in the third quadrant, in this third quadrant, sign is going to be negative because only tan is is positive. Sorry. So now you reduce the angle. It's going to be 180 plus 30. All right, and then it's minus that, and then after that you use your because now you have your your not the, yeah, yes, you have your reference angle. It means you did your reference angles, then now you have got your sine 30, which you can use special angles. All right, and then so this one is the last thing that we gonna deal with. So they said determine the quadrant, then the sign of the ratio, and then the angle. All right, so this is just to sum up everything that we learned today. So we're gonna say, all right, what can we do? All right, we say um the all right, so what's happening with my pen? Okay. All right, yes. Now we are solving this. Ne? So we say, okay, we are having cos 13. All right. Remember, we need to determine the quadrant first and the ratio. Then we know that we're having cast. We're having cast. Then where is 130? Remember, this is 180. This is 270. This is 0. This is 90. Sorry about that. Then 130, so it means 130 is in the second quadrant. So for example, you will say, okay, this is the second quadrant. This is the second quadrant. Then we say, but now, it in the second quadrant, only sign is positive. So it means the sign is going to be negative. All right. And then after that, they say determine the angle. So it means now, I hope you're following. All right. Then now we'll be able to determine the angle because we have seen that this is negative and is in the second quadrant. Now we can easily determine the quadrant. I hope it makes sense. So you can say, well, from this we can say, well, if we're having this, let's do this and say, because this is exactly like negative cos, all right, and then 130, so it's 180 minus 130, All right, then it will be 180 plus 50. Oh, my pen stuck, can't write anymore. What's happening? Yo, my pen froze. Oh, yeah, sorry about that. Yes, no, but not 180, but it should be minus to give 30 to be give us 130. Sorry about that. So then you'll say then now it will be minus a cos of 50. Then here you see 180 plus 80 is in the third, okay, it's in the of a third quadrant, it's in the third quadrant, and then where is this the sign? It will be negative. Then you will say, well, um I know that it's in the third quadrant and sign is negative, so therefore you'll just have minus sine of theta. Then let's now simplify everything all together. Then we can say now sine 80 plus sine 180 plus whatever. So and then now we start to determine the signs. We know 180 plus is this one. We already found it. We know that it's in the third quadrant, but sign is negative, and then multiply by, and then 180 minus is in the in the second quadrant, and in the second quadrant sign is positive. All right, and indeed, so you'll say sine theta multiply by cos of theta divide by, then cos 180 plus theta. 180 plus theta is here, but only is in the third quadrant, but only tan is positive, so it means we'll have a negative cos of theta, sorry. Then sine 360 minus is in the fourth quadrant, but only cos is positive. It means we'll have minus sine theta. Then we can simplify everything together. So this and that will cancel each other out. And then what else? Then cos and cos will cancel each other out. Then what are we having now? We are still having this sine. We'll have sine of we'll have the sine of theta, because I think we did yes, we still will have sine. All right, yeah. So that good people was to just give you the basics of the trigonometry. That is to say, everything. If they need you to simplify to do other things, you need to combine everything. Trig ratios. You know the core ratios, the reference angles or the special angles. When you're given the negative angles, what you do, you add 360 and all those things. All right, you add them all together to give you a solid thing. All right, so this was just the basics. We combined everything so that when you are solving the proper questions now, it's going to be easy. So that's why I said that these are the basics of the trig functions. I hope you enjoyed this session. If you are new to this channel, please hit that subscription button, and but above all, don't forget to hit the notification button below so that you get notified once we upload new content. Don't forget that this is the MJ's a brain boost, the brain boost that actually work. And I always like to say, until next time, cheers.